Hello, my name is Javier Hernando Beltrán Velázquez. I'm a business administration student. Today, I'm doing this recording in regards to tax number 2. This is the grouper part, as in the prior activity, my classmate didn't appear, so I had to do this by myself. On this stage, the activity guide gave us 3 exercises. The first one is called dual sensibility. We do the Here we have the company produces some, in this case, porcelana, 3 types of porcelana. They give us the ingredients necessary to produce each kind of type of porcelana. They give us the restrictions or the amount of ingredients available to make the job. We put the equation. The first step with this by using the primal method. Here is the result. Sorry. 8,532,258 as a result of the objective target, and the company must produce only 2 types of porcelain, in this case, type 1 and type 3, on this amount, 112, and the second, 475.74 units to reach this goal, this target. We prove this by using the solver tool. Here is the objective. Here are the restrictions. And the result was the same. It means that the exercise is fine. From the primal, we pass to the dual method. Here we put the problems to minimize. I did the charts, and as in the other exercises we did, we use the Gauss-Jordan method to get the result. Here is the result. The company, in this case, must produce porcelain type 2 and porcelain type 3 on these quantities to get the best cost. We prove this by using the solver tool. Here we have the same quantities. Just porcelain type 2, porcelain type 1, type 3, pardon. And from this, we pass to the exercise number 2, that is called sensibility analysis. In this case, the company Western Group produces pasta. Here is the profits that the company gets by selling each type of pasta. From the pasta type 1, the company gets $2,000. For the type 2, the company gets $2,050. For the type 3, the company gets $2,100. Here is the ingredients necessary to produce 1 unit of each one of these. Here is the restrictions or the ingredients available to do the job. Here we put the equation. Here we did the charts, and we use the Gauss-Jordan method again. To get the result, in this case, the company must produce pasta type 1 in 71.43 units and pasta type 2 in 571.43 units to get a profit of 1,340,285.71 US dollars. We prove this by using the solver. As you can see, we have the same result. It means that the problem is okay. And from the solvers, we get with the sensibility report. From this, we did the next steps. That it was what happened with decrease or make reduction of coefficient. If we reduce the coefficient, this is the result, and the company has to produce pasta type 1, pasta type 2, in the same quantities. As you can see, the profits also decreased, and we use increase the coefficient producing the same quantities. The profits also increase. And what happened with increase of the availability of ingredients? The result is the same that we get when we increase the coefficient. And when we reduce the available ingredients amount, we get the same result as when we increase the available. So the company must produce pasta type 1, pasta type 3 in the same quantities, and the company get the same profits. Then we pass to the post-optimal analysis. In this case, the company produces NDF panels, 3 types of NDF panels. For this, we use the artificial method. Here, almost the same states. We use the Gauss-Jordan method. We get here the result. We compare the result to prove that is fine by using the solver tool. The company gets profits from 35,896,226.42 US dollars by producing pasta type 3 in 1,108.49 units and pasta type 1 in 801.88 units. The same that tells. In the solver, we did the same way as always. We put here the restrictions, we put the objective or target. Here is the opposite from the primal method. From this, we get the sensibility report, the same we did in the exercise number 2, with almost the same steps. we change the coefficient by increasing or and reducing coefficients. We change the availability of ingredients. And the difference, we make a new restriction. The restriction is a new ingredient using by producing the panels. In this case, we put carton reciclado. This is the amount necessary to produce each one in each kind of products. Here is the result. And what happens if we produce a new product? In this case, we produce an MDF panel type 4. Here is the ingredients. And the result, when we put a new ingredient and we produce a new product, the result is not affected by this by these changes. So we get the same result. The profits are 35 millions 896,226.4 US dollars by producing panels type 1, panels type 3. I think we compare with what happened when we add a new product. The result is the same. So these changes doesn't affect the result. And as you can see, linear programming give us the best choices, so to check, to verify, to compare what is the best choice to get the best cost or to maximize profits. Thank you very much.